Hi, I'm Matthew DiMaggio. I'm a student at Lawrence Technological University. I am a senior in architecture, and I am a fellow at Ballard International studying robotics. My research project at Ballard International is about creating a general-purpose, low-cost, and accessible robot vision system for industrial robotics for use on both standard industrial applications and architectural applications. The reason I wanted to do this research was for two purposes. The first is because robots don't really understand 3D space. I've noticed that lots of robotic problems require a full awareness of 3D space, but without hard coding, there is no way to get robots to understand 3D space. For a robot to have full control and full understanding of its surroundings, an operator has to program that manually. There are systems that allow robots to track objects visually, but very rarely in full space. And the ones that do are very expensive and very inaccessible. So I want to create a system that is cheap and accessible. The second reason is because there are a lot of repetitive and mundane tasks that can easily be automated and allow robots to do those very quickly and very easily. Having a system that allows robots to screw in 10,000 light bulbs into a building, well, the robot will need to be able to find those 10,000 different light bulbs. So if you have a system where you can very easily point the robot to different locators, then it can do really any task. So what I want to do is create a cheap, accessible, low-tech system that allows a robot to track 3D space very easily. And I want it to be general purpose. I want it to be universally applicable. The way I tackled this project was by splitting it up into 3 phases. The first phase was my robot practicality phase, a understanding of the robot phase. The second phase was developing the camera system, and third phase was the integration phase, where I put everything together. So phase 1, the robot practicality test, is more like the practice phase of the robot. This gives me an opportunity to program the robot to do one of my practical demonstrations, in this case, screwing in a light bulb, in a more traditional method, where everything in 3D space is hard-coded. By doing this, I get an opportunity to see what I need to do in order to integrate the camera into the robot software easier, and what tasks it needs to accomplish. Phase 2 is all about developing the camera. To do this, I used a small computer called a Raspberry Pi and a programming language called Python to take a picture of a tag called an Aruco tag, which looks like a QR code, to translate that into position data. During this phase, I used 2 other programs, Rhino and Grasshopper, to take the data from the camera and to visualize where the camera thought the tag was in space. This allowed me to quickly iterate over the camera's code to calibrate its accuracy and its speed and how well it was actually taking something and correctly putting it into space. Phase 3 was about integration. During this phase, I wired the camera to the robot and began developing how they would communicate. They did so using very simple input-output signals in order to maximize how compatible this camera would be with many types of robots, which meant I had to develop something called a handshake protocol, which very basically means that the camera would need to send a signal to the robot to tell it that it's ready to send information, and the robot would have to send a signal back to the camera to say that it's ready to receive information. And this would go back and forth, and then the information would actually get sent over. And it would do this a few times to send all the different numbers over. Once the handshake protocol was set up, all that was really left was to hit play. And the robot found a tag using the camera in space, and it did successfully move to it and rotate to it without any user input. That was it. So, the results of this research. Well, I would consider it a huge success. The basic goal was simply to prove that you could use a very simple camera and very simple technology to locate a position in 3D space with position and rotation and communicate that to a robot. which absolutely was proven to be a viable concept. There are a few complications, which with more time, I would hope to be able to develop further. The first one being accuracy. In order for the robot to do a practical demonstration, like screwing in a light bulb or painting a wall, it needs to be able to reach that position with very little error. And right now, while the robot does reach the final position, it does have too much error. So if a practical demonstration was attempted, there is the potential for damage to the equipment. The other problem is speed. The computer that's running the camera, the Raspberry Pi, is relatively slow, which is due to both availability and cost problems. If I were to continue developing this, I would likely upgrade the computer to a much faster one. Still a Raspberry Pi, but faster. The other problem with speed is the handshake protocol. Now, while it does work very effectively, I have hard-coded limitations in the handshake that doesn't allow it to run at max speed, because there are also problems with one of the programs, either the robot or the camera, outpacing each other and getting out of sync, which does completely screw up all of the data going between the two. So with those two issues, it does make the process fairly slow, which does limit the tracking to only stationary objects and can't do any movement or real-time tracking. So in conclusion, I would consider this project to be a huge success. I absolutely proved that the concept is viable to use a simple camera to communicate positions to a robot, which I'm very happy about, and I would love to see where I can develop this project in the future. At Ballard International, with this fellowship, I really love that I was given a lab space to have the freedom to pursue the project I wanted to research. And in the warehouse, always being surrounded by people who are extremely knowledgeable and always available to help me learn new things and solve new problems.